I already showed you how you can get the equation of a line in a slope-intercept form. It means the function notation. If you want to have a linear function, you can put it in function notation, and that will be the slope-intercept form. That is when you calculate the slope, you have the y-intercept, so you just represent your linear function in terms of mx plus b. In this video, we're going to see the other forms of the linear functions that will be applied in other topics and in other parts, and you can use it depending on the situation that you have. So in this case, we're going to see the point slope form and the standard form. Let's go to see how to get the function in point slope form and in a standard form. Now, if you remember, this is the problem I put you the last video. So we're going to get it in, we're going to calculate the gradient first. So we're going to calculate the gradient. Remember that the gradient is just rise over run, or y2 minus y1. So I'm going to name my points x1, y1, x2, y2. And now I'm just going to get my gradient. So minus 4 minus 2 over 5 minus 3. So in this case, this will be minus 4 plus 2 over 2. Minus 4 plus 2 is minus 2 over 2. So my gradient will be 1. So the gradient of this line is going to be 1. Now, the y-intercept form is when you want to put your equation or your linear function in the form mx plus b. So that's the form that we check as slope intercept form. I left you as a practice in the last video for you to work on this part. So I hope that you get the slope intercept form. So I'm just going to do it very quickly using the point 3, negative 2. So if I know that the gradient is 1, so when y is negative 2, x should be 3. So 3 times 1 is 3 plus b. So in this case, b is going to be minus 5. Minus 2 minus 3 minus 5. So my line in this form will be x minus 5. Okay, this is what we call the slope intercept form. The other form that we can use is called the point slope form. Point slope form of a linear function is when you want to represent the linear function or the linear equation, you want to express it in terms of one point that is not necessarily the y-intercept. So in a slope intercept form, we have the intercept, the y-intercept. But in a slope intercept form, we don't care about the y-intercept, we just care about one point in which the line crosses. And this is the form. So point slope form is when you put your equation point slope is when you put your expression y minus y0, let's call it y0 to any point, m factor of x minus x0. But what means x0 and y0? x0 and y0 is just the point or a point that the line crosses. Okay, the line crosses this point. This is very important in this case. In this case, it's clear that your line crosses by the point x0, y0. This is what you need to bear in mind, that the line crosses this point and you have this slope. So let's just show in our case. Look at that. In our case, I know that the gradient is 1 and I know that my line crosses by one of these points. So for example, I can use point slope form I know that the gradient is 1 and passes by the point 3, negative 2. Yes, 3, negative 2. So it means that the point slope form is y minus 2, so I'm going to change by positive, equals the gradient that is 1, so I can put 1, but I'm not going to. Remember that when you put a 1 multiplied, you don't need to put it. X minus 3. This is the point slope form of this line. This line in point slope form is the same as this line. Okay? You can tell me, hey Hugo, but here is the thing. This line also crosses by this point, by the point 5, negative 4. Yeah, so I can put y plus 4 equals, I'm going to put the parentheses. I put the parentheses just for you to remember that here you multiply the slope. X minus 5. Yes, both point slope forms represent the same line. And this is the trick with point slope form. In point slope form, you can have infinitely many equations for your line because you're representing a point that crosses your line. It's not like what you do when you have y-intercept form or a slope-intercept form. In slope-intercept form, you just have only one form. And this is the good thing of point slope. You just need to have the gradient and one point. Obviously, these points should represent the same equation, the same linear function. So if I solve it for y, it's going to have the same answer. I'm going to do this part. And finally, the third form is what we call the standard form. The standard form. And the standard form of a linear function is just when you want to put all the variables on one side and you want to represent it equal to a constant. So you're going to put all the variables on one side equals to the constant. Let's see it in our example. So in our example, I know that y equals x minus 5. So I'm just going to, I have the equation y equals x minus 5. So now I'm just going to move or add or subtract terms in a way that I got on one side all the terms with variables and on the other side all the terms only with constants. So in this example, for example, I can subtract by y to get the y on the other side, and I can add by 5. So it will be 5. Okay, add by 5. I'm going to put it like in the way people like. Plus 5, and I'm going to subtract y. So minus y, and here minus y. Something like that. So in this case will be 0, and I got 5 on this side, and here I got x minus y. By notation in a standard form, we're going to require that the term, the coefficient that multiplies x is going to be positive. So we're going to tell, hey, let's a greater than 0. Okay, we're going to establish this. It's not a problem if you don't put it, but it's better if we set it in this way. And this is the standard form of a line. The standard form of a line is when you put the expression in terms of variables on one side and constant on the other side. If you want to write it like in the way I wrote it here, it will be x minus y equals 5. And this is how you can show your work in a standard form. And that's it. So as you can observe, we have three ways to represent our linear function. The first is the slope-intercept form, when I want to get it into function notation, when I want to put it as a linear function. That could be the best idea. The second one is point slope, when you just want to have your linear function in terms of one point. one point that is of interest for you. And the third form is a standard form, that is when you want to represent all your variables equals to a constant. So this is the standard form. As an exercise, if you watch the last video, as an exercise, I suggest you to check what happened with this linear function, 6/5 of x plus 17/5. So the line crosses by -2, 1, and 1. So how would you do the point slope form of a line whose gradient is 6/5 and passes by the point -2. Okay, how would you do it? And put it in a standard form. If you have any question, remember to post the comment in your video, to like the video if it works for you, and I hope that this helps you to understand how to represent linear functions in point slope form, standard form, and y-intercept form. See you in the next video. Bye bye.